Dear students, welcome to CR's digital classes. Today's concept is mode. Let us discuss about mode. Mode is nothing but the repeated value or the highest value. Let us check it out how the definition goes on. So mode is the value which has maximum frequency. In the sense, the highest value in the given data becomes our mode, or the value which occurs maximum number of times than any other value in the given set of observations is called mode. So nothing but most repeated value. So either it becomes a maximum value, that is the highest value, or the most repeated value in the given data. So again, to identify mode, we have different types of data as usual, like individual series we have, discrete series we have, and continuous series we have, right? So any series they will be giving, in that we need to find out mode, means you have to go for highest value. If you have repeaters, we'll go for the most repeated value. No repeaters in that data, consider the highest. So generally for individual, like this only it will go on, the highest or the most repeated values. But for discrete and continuous, we have some formulas, we need to deal with that. Exactly, the definition is the same, the highest value or the most repeated value, but based on the data we'll be going with different formulas. Now why we'll go for mode? Let us check it out why mode actually is utilized. Mode is used whenever data is like most repeated values are there, that averages overall representation. If you want to represent the entire data, more repeated values are there. Simply if you pick one of them, so most highest in repeateds, so that becomes the mode. Like generally if you go for shopping and all, if you check, particularly if you go for to buy some sandals, chappals, if you check it out, most different designs you can obtain for like sizes for 6 and 7 numbers. If you go, if you have a big number like 10, 11, options will be very less. Why like that? Anytime you have checked out. So because most of us has the foot size as 6 or 7, so most different varieties, lot of varieties we will have in that particular, because those who are customers, those are the have that foot size maximum to the 6, 7. So whatever the shopkeeper we have, he'll be keeping lot of varieties for that particular size, because many will buy in that range. So the in such situations, mode formula is utilized, most repeated, right? So most utilized thing we will be keeping in a shop, so that most highest profits you can get. Like if you is keeping small size, like 4 5 like that, most of them will not prefer. We don't have that size, most of them, because average height we have for 5.5 like that. So average foot size mostly we have 6 to 7. So for that, what he does is most repeated size whatever you have, in that lot of varieties he will be keeping, so that many will buy that particular size. So in this way, mode is utilized in our real life. So most repeated data, go for mode formula. So that is just an example how why we will be using mode in our lively example for that. So now let us check it out how mode is done for the problems. Now let us go for the individual series. How we'll obtain mode in individual series. So step 1, arrange the data in ascending or descending order. So we have to arrange the data in ascending or descending order is the step 1. Next, check which value is repeating maximum number of times. The value repeating maximum number of times is considered as mode. Just now we discussed, right? Highest value or the most repeated value becomes our mode. So here, after arranging in ascending or descending, check it out, highest value, that becomes our mode. Now let us check it out that using an example. So here is an example. Check it out. Marks they have given. We need to find out mode for that. So single data we have, that goes to individual. We know already. So let us arrange it in ascending order. Marks arranging in ascending order, in the sense least value to the highest value. 5, 10, 15, 18, 20, 25, 29, 30. Least to highest I have arranged here. Now how to identify that? To identify the most repeated or the repeated values or the highest, what I have done is, here number of times occurs, I have wrote the title and I want to check it out how many times it has repeated. So 5 only one time, so write on 1. 10 also one time, write on 1. 15 one time, 1, like that, all 1 times I have wrote here. Next, here 29, 3. Why? Because 3 times it has repeated. Check it out here. 29, 29, 20 times. 3 times it has repeated. While arranging in ascending order, only single time I wrote here. Now I am checking out the original data. From there I have identified 29 as repeated 3 times. So I have wrote 3 here. So and 30 single time 1 here. So while arranging in ascending order, no need of writing how many times it has repeated, because next how many times it has repeated we are writing separately. So this is how mode is identified. I wrote all that, and 3 times 29 has repeated, so 29 becomes a mode value. So therefore mode is 29. So this is how we'll find out mode for individual series. Okay, now let us check it out how mode is identified by discrete data. So discrete data, we have two ways to identify the mode. First one is inspection. Inspection in the sense, by seeing the data we can identify, that is highest value if it is there, that becomes our mode. If highest value we don't have, grouping analysis and analysis table, grouping table and analysis table will be doing. That I'll explain using a problem. Okay, let us check it out how the inspection method will go on. So maximum value or the highest value is selected from frequency column. So simply maximum or the highest to select it, and then step 2, the value corresponding to highest frequency value is considered as a mode. So identify the highest value from the frequency, its corresponding x value becomes a mode. Just like median and mean we have learned, right? Similarly here also we'll identify the highest value in frequencies, but reflection, that is the value for mode, becomes our x value. So let us check it out. Through example let us check it out. That some example they have given as size of garments, number of persons. So in that let us find out the mode. So what I said, just arrange data, and let us by inspection itself we can identify here. Check it out, the highest value from the frequencies, that is number of persons, becomes a frequency. So check it out, the highest value is 65 we have. Its corresponding x value, that is your size of garments, becomes your mode. So that is 30 becomes a mode. This is called inspection method. Means by seeing you can identify, because it's the highest value already we have in the data. Simply consider the highest value as a mode from the x values, not the frequency. Frequency highest you have to check it out, its corresponding x value becomes a mode. So that is how we have got the mode. This is by inspection method we can say we can identify the mode. Okay, now let us check it out. The steps for calculating mode for continuous data. So continuous data, we know class intervals they'll be giving, right? So for that we have steps to identify that mode. Let us check it out. So what we have to do here is we have to identify the modal class. In a problem, we'll clearly explain how it goes on. So we need to identify modal class first, just like median class we'll identify in median. So similarly here also modal class we have to identify. To get the modal class we have two ways, that is by inspection. Inspection just now we have done in discrete, right? By saying we can identify the highest and corresponding values. Similarly by inspection, by seeing if you can identify the highest value, there we can get the modal class. Or sometimes we'll not get the highest value, we'll get the repeated values. So whenever we have repeated values, we have to go for the second, that is preparing grouping table and analysis table. That will I'll explain now how that goes on. So step 2, here we have as formula for mode. Mode is equal to L plus delta 1 by delta 1 plus delta 2 into I. So L we know always will consider lower limit. If it is for mean class mode, here we have, so modal class will consider. So L is equal to lower limit of modal class. So modal class we have here, F1 is equal to frequency of modal class, and delta 1 goes as mod F1 minus F0, where F0 is preceding value of F1. Preceding means before value. Before value of F1 becomes F0. In a problem, I clearly explain how it goes on. Mod means whenever if you get negative values, still you have to consider as positive. You have to make negative to positive values. So for that we'll take mod. This mod we'll call this one. So okay, mod in mod will be writing F1 minus F0. And that becomes our delta 1. Now delta 2 is mod F1 minus F2. That is again, what is F2 means? F2 is succeeding value of F1. Succeeding is next value of F1. So I, as usual, class interval, difference between the highest and lowest value of the class interval, you will get the I. Now let us check it out an example to get this formula, to get the mode. Let us check it out an example. So here is an example. Calculate the value of mode from the data given below. So check it out. It's a class intervals data, means it's a continuous data we have. Okay. So continuous data marks the class intervals and the frequencies we have. So now formula becomes mode is equal to L plus delta 1 by delta 1 plus delta 2 into I. Now how to find out that? Let us check it out. So here by inspection method we can identify. So because check it out here, the data, whatever the values we have, we don't have any repeateds in the data, in the frequencies we need to check it out. If you don't have repeateds, well and good. Consider the highest value, that becomes a mode class or modal class we call. So check it out which is the highest value here we have by inspection, that is 15 we have. So 15 is the highest value we have. So that we have to consider as a modal class. So that class intervals are 50 to 60 we have. So this is how inspection method will go on. We'll just identify the highest frequency. From there we'll identify that particular highest value as a modal class. So modal lies in the class interval of 50 to 60, because the highest frequency is 15. Okay. Now using that, let us identify F1, F0, F2 and all. Let us go back to the table and let us identify what we considered. F1. F1 is exactly the highest value whatever we have identified. So that 15 becomes our F1. Now F0, what we have got? F0 just now we discussed, right? F0 is nothing but the preceding value from the frequency, right? So that is your 12. So 12 becomes F0. Then downside value from the F1 becomes your F2, that is succeeding value from the mode class, that is F2 is next to the 15. So upside value we will call preceding, that is F0, and downside value we call as succeeding, that is your F2. So I wrote all the values. Now lower limit also I require, right? So lower limit of the mode class becomes our L. So this one mode class or modal class we will call. Okay, so this is how we have identified all the values. I is difference, 60 minus 50 you take, that is 10, becomes your I. So all the values I've got. Now let us go for the formula substitution. So what is that? Delta 1 what I had? Mod F1 minus F0 we had, right? So I have substituted here. Check it out. 15 minus 12. Anyhow, it's a positive, because highest minus lowest, you'll get the positive. That is 3 is your answer. Next to delta 2 formula is F1 minus F2 we have. So that is your 15 minus 12 again. So again 3 we got. I is class interval, that is 10 we got. So let us substitute all the values here. Mode is equal to 50 plus 3 by 3 plus 3 into 10. That goes to value as mode is equal to 55. So this is how we will obtain the mode for continuous data. Okay. Thank you.